Okay, so welcome to the next session of our NMR, and in this session we are going to learn about NMR spectroscopy. I mean to say actual syllabus of NMR spectroscopy. So actual syllabus of NMR spectroscopy means whatever the points or whatever the classes I took before today, that classes were very important one, because whatever those classes are there, those classes were was completely basic. And if you got clear with the basic those classes, except that nuclear spin class, I mean to say ये जो आज तक जो कुछ भी एनएमआर के क्लासेस मैंने लिए थे वो बहुत ही इंपॉर्टेंट थे, क्योंकि आप लोगों का बेसिक क्लियर हो. ओके, then if you have completed those recordings, then you can be clear with the recordings, which I'm going to start from today onwards. Okay, before going to continue the syllabus, or before going to continue the points which we are left with from our syllabus, I would like to share some slides which I have prepared for you guys. And whatever these slides are there, these slides will be helping us to explain the to explain me the NMR concepts. Okay, now what type of syllabus is there, or what type of things are there, or why to learn NMR spectroscopy? This question may has arisen in your mind. Okay, so when you think about any spectroscopy, as I told you many times, each and every spectroscopy is very important itself. Why? Because each and every spectroscopy gives you very important information regarding the unknown samples. What I'm going to tell you, I think that you are getting clear. Means what? Any spectroscopy, that might be UV, IR, NMR, mass, many more number of spectroscopies are there, and each and every spectroscopy gives you information regarding the molecule with its for example, as our IR is giving us the scratching frequencies of different functional groups, then after UV gives us information regarding the conjugated compounds, or whether it is conjugated or it is not. Also, it gives us info regarding the ketonic functional groups, or what a type of functional groups are there, is there is any extended conjugation. Okay, let me continue with the Raman. Then Raman spectroscopy gives the info regarding the molecules which are active or inactive in the region of that Raman spectroscopy. So see, whenever you are here with the simply your NMR spectroscopy, at that time the most important application of NMR spectroscopy is in the MRI detection. In what? MRI detection. Now what is mean by this MRI? MRI is nothing but see, whenever a patient is admitted into the hospital, and if doctor is not getting what happened with that patient, then nowadays every doctor says, or every doctor suggests to the patients, please try to please take out, or please just do one thing before any prescription, or before any what we can say, before any treatment, that doctor suggests to the patient, please do CT scan, or please do MRI. Those patients who have brain problems, or those patients who have the another problems. What do I mean by this thing? I mean to say, whatever this NMR spectroscopy is there, this NMR spectro, why to learn this NMR spectroscopy? Now you may ask me, ma'am, is only one application of NMR spectroscopy is there in only MRI? Is there is any other application in our day-to-day life which is related with the NMR spectroscopy? Its answer is yes, but except those applicative part of NMR spectroscopy. Now from today onwards, we will deal with only application which is related with simply, that one is nothing but simply what can we say as in the chemical compounds or chemical substances analysis. Now, whatever these 5 minutes introduction is there, it was for your just conveniency, just you should be comfortable with the topic. Now, I think you guys are pretty convenient with the topics as we have covered already some basic topics. But see, when you are here with the topic NMR, at that time, first of all, let me share the slide. Wait a minute, slide is loading. Yes, it is right in front of you. So, as in previous classes, we discussed about the nuclei which are active in NMR spectroscopy. Now, here I'm not going to tell you what type of nuclei are active for NMR spectroscopy. I'm taking here pause of 2 seconds. You just recall what type of nuclei I told you in my previous classes which are NMR active. Now, see, I'm taking some pause. Yeah. Now, I think you must have memorized those applications which are about simply NMR which are about an NMR active nuclei. Now, let me continue with the thing, which is here right in front of you. What are the another applications of NMR spectroscopy? It is right in front of you. And what are those applications? See, whenever we are here with the applications of NMR spectroscopy at that time, NMR can be used to study the biofluid cells, perfused organs, then by macromolecules such as nucleic acid म्हणजे DNA, RNA, कार्बोहाइड्रेट, प्रोटीन, पेप्टाइड, इन सब के लेबलिंग के स्टडीज के लिए हम किसे यूज करते हैं तो NMR स्टडी को यूज करते हैं. देन आफ्टर also we can use, आप बोलोगे कि मैम can we use this NMR spectroscopy in only life sciences or in only biochemistry? No, its answer is absolutely no, because whenever we are dealing with the NMR at that time, NMR we can use in also physics as well as in physical chemistry to study the pressure diffusion, liquid crystals, liquid crystal solution, membranes, and the rigid solids. Also, NMR can be used in the food sciences. I think you guys are clear with the NMR applications. See, whenever you have these NMR applications, then after we will go towards the next point, which is related with the NMR spectroscopy. And what is that point that I'm going to share with you? And it is nothing but, let me share firstly the slide. So first of all, first thing first, to learn out the NMR spectroscopy, which is nothing but the principle of our NMR spectroscopy. So what is the principle behind our NMR spectroscopy? To learn out this thing, I would like to ask you, do you know the things which are related with the NMR spectroscopy? What do I mean by this thing? See, whenever we have NMR spectroscopy, at that time, there is a nuclei which is NMR active. Obviously, those who have I value which is not equals to 0. Am I correct or wrong? Spectroscopy. What do it mean or what it tells us? These principles of NMR spectroscopy is telling us information regarding the spin of our nuclei. What does it mean? It means अब ये जो कुछ भी NMR होता है तो NMR में क्या होता है? NMR itself, let me take a pen firstly. NMR matlab nuclear magnetic resonance. Nuclear means nucleus, and whatever this nucleus is there, it's a magnetic resonance is there. As I taught you all these things in my earlier classes, and whatever those classes are there, I request you all, please watch, please again and again watch those classes to clarify your basics. And whatever the long form of this NMR is there, that I told you in detail in my earlier classes. So see, whatever this NMR is there, this NMR, when you have a nucleus which is NMR active, now this nucleus, as I show you in the diagram, or let me try to take another color with which you can observe it clearly. Yeah, right. So see, जब कभी भी हम एनएमआर के बारे में पढ़ते हैं तब हमें पता है कि हमें यहाँ पर मैग्नेट्स की जरूरत होती है. What do I mean by magnets? Magnets means what? Magnet, it will create magnetic field, and it will create magnetic field means what? It will have two poles. And what type of two poles are there? North pole and the south pole. So see, whenever you have these two poles, at that time, if you are placing them means whom? To the NMR active nuclei. For example, here I am showing you a NMR active nuclei by this round sign, and when this is placed in the your magnetic field, first of all, if you have not started any magnetic field at that time, as again I told you in my previous classes how this here NMR active nuclei is before or in the absence of magnetic field and in the presence of magnetic field, and its alignment, its splitting, everything I taught you in previous classes. So if you haven't completed those recordings, please go and watch those recordings and then only come to this class, because if your basics are not clear, I think you cannot be clear with this, but you can continue with also the class, because I'm trying to clear telling you everything. So see here, whatever this your nuclei is there, this is actually first of all in the absence of magnetic field. Now we are placing it in the our magnetic field. When it is placed in the magnetic field, at the time what happens, it have means this nuclei is NMR active. This nuclei is NMR active, and when you say this nuclei is NMR active and you have placed this nuclei in the presence of magnetic field before any field, listen carefully, listen very very carefully, again I'm telling you why. Because these things are very very important for our. So see, whenever you have this your this your NMR active nuclei, and whatever this NMR active nuclei is there, this NMR active nuclei tells us information which is regarding this nuclei. Means ये जो कुछ भी न्यूक्लियाई है, ये न्यूक्लियाई फर्स्टली जब वो इस एक मिनट जब वो अब मैग्नेटिक फील्ड में प्लेस नहीं किया था, तब वो एनएमआर एक्टिव न्यूक्लियाई कैसा था, उसको स्पिन तो रहती है, नो डाउट, वो खुद की तरफ घूमते ही रहता है, बट वो कैसे भी किधर भी, मतलब कि विद द हेल्प ऑफ डायग्राम आई विल बी शोइंग यू, एंड व्हाट इज इट, it is right in front of you guys, and what is that is nothing but नो एक्सटर्नल मैग्नेटिक फील्ड म्हणजे मतलब कि ये जो कुछ भी आपके न्यूक्लियस है, अभी जैसे कि मैंने आपको बताए थे, वो रैंडम मोशन में रहते हैं, कहीं पर भी कैसे भी घूमते रहते हैं, बट as soon as you apply magnetic field, and a magnetic field is denoted by the notation B0. What is that? B0. Whenever you look towards the word, or whenever you are saying that you are applying magnetic field, at that time you are applying B0, that is magnetic field, which is एक्सटर्नल वन, विच इज एक्सटर्नल वन मतलब कि मैग्नेट की वजह से जो फील्ड तैयार होती है उसको हम बोलते हैं मैग्नेटिक फील्ड. एंड एज यू नो वेरी वेल एवरीवन, व्हाट टाइप ऑफ मैग्नेट्स आर दिया, मतलब बहुत टाइप के मैग्नेट्स हैं, बट उसमें से उनके पोल्स कौन से हैं वो मैं आपको पूछना चाह रही हूँ. दैट इज नथिंग बट द नॉर्थ एंड द साउथ पोल. नाउ let me continue with the main point which I want to tell you is, when you are placing all these nucleuses in the presence of magnetic field, and now at this time all the nucleuses can be aligned, they can get aligned with the external magnetic field. What I told you, ये जो कुछ भी न्यूक्लियसेस है, ये न्यूक्लियसेस when you are placing them in the presence of external, let me take another pen. So ये जो कुछ भी आपके अब न्यूक्लियस है, ये न्यूक्लियसेस आप जब भी एक्सटर्नल मैग्नेटिक फील्ड में आप उनको रख दो तो वो एक तो एक्सटर्नल मैग्नेटिक फील्ड के मतलब कि आपको दिखाती हूँ इस डायग्राम में, एक तो वो अपोजिट मतलब कि नॉर्थ यहाँ पे है, साउथ यहाँ पे, तो इस न्यूक्लियाई का साउथ नॉर्थ यहाँ पे होगा और साउथ यहाँ पे होगा, मतलब कि दीज आर अलाइनिंग विद द एक्सटर्नल मैग्नेटिक फील्ड. Try to memorize, try to recall all these things which I taught you in my previous classes, in my previous recordings. I'm telling you all these things again. And now if the external magnetic field is very very high, or to this external magnetic field, to this external yes, to this nuclei, if you are passing over the actual frequency or actual source of your NMR nuclei, NMR, what we can say, spectroscopy, then this nuclei can absorb the radio frequencies. Why? Because as we know very well, this NMR spectroscopy is having this NMR spectroscopy is having simply radio waves as a source of light or as a source of your NMR spectroscopy. And now after this, whatever this your radio waves are there, when resonance takes place, what is mean by resonance, that I'm going to tell you, but before that, ये जो कुछ भी आपके that I'm going to tell you but in another class. But before that, ये जो कुछ भी रेडियो वेव्स होंगे ये आपके न्यूक्लियस पे गिरेंगे, एंड इसकी जो मैग्नेटिक फील्ड है, मैग्नेटिक फील्ड एंड ये रेडियो वेव्स जो कि आपके इस न्यूक्लियाई को अपोजिटली अरेंज कर पाए, या फिर ऐसे ऐसे मतलब कि आपके इस न्यूक्लियाई को वो मूव अप कर सके, मतलब वो आपका न्यूक्लियाई मूव हो सकता है in the presence of external magnetic field. And how it can be moved, that I'll be showing you how I showed you, I think I showed you. Can you please tell me, anybody, if anybody is live, can you please tell me? Yes guys, because this session is considered to be recorded. Is there is anybody who is live? Yes, is there is anybody? नाही तर मग मला एक्सप्लेन करावं लागेल. Have I or not? अरे are you there?
Yes, ma'am.
सो ये बोला था क्या मैंने, इन द प्रेजेंस ऑफ रेडियो वेव्स वो कैसे मूव होते हैं, अलाइनमेंट ओरिएंटेशंस बोले थे मैंने 2i+1 की हेल्प से. उसके बाद का बोला था क्या कि न्यूक्लियाई कैसे अरेंज होते हैं, वरना मुझे व्हाइट बोर्ड लेके एक्सप्लेन करना पड़ेगा, इसलिए पूछ रही हूँ.
No, ma'am, वो नहीं हुआ था.
ओके चलो, लेट मी ट्राई टू एक्सप्लेन यू दोस थिंग्स, बिकॉज वो अगर से एक बार समझ गए ना आप, तो आप लोग बहुत ही अच्छे से एक्सप्लेन कर पाओगे एनएमआर स्पेक्ट्रोस्कोपी. सो with the help of diagram, I'm just trying to write it horizontally. सी, ये आपका क्या है, नॉर्थ पोल है एंड ये आपका साउथ पोल है. आपका एनएमआर एक्टिव न्यूक्लियाई अभी क्या था, ऐसे अपोजिटली अलाइन होता है जैसे कि इसकी नॉर्थ एंड साउथ पोल. व्हाई? अपोजिट attracts, that is why because opposite attracts. Now whenever you have this your magnets at that time, what happens, ये भी मतलब बार मैग्नेट ही है. हाँ, ओ वेट. हाँ, सो ये जो कुछ भी साउथ पोल है, नॉर्थ पोल है. अब इसके बाद में आपके इस न्यूक्लियाई पे आप क्या कर रहे हो, रेडियो वेव्स डाल रहे हो. क्या डाल रहे हो, रेडियो वेव्स डाल रहे हो. अब ये रेडियो वेव्स जब आप डालते हो, तब आपके इस न्यूक्लियाई को मूव होने के लिए, रोटेट होने के लिए, जो कुछ भी अप्लाइड मैग्नेटिक फील्ड है, वो अप्लाइड मैग्नेटिक फील्ड तो आप बढ़ा सकते हो, या फिर आप ये जो रेडियो फ्रीक्वेंसी है, ये रेडियो फ्रीक्वेंसी चेंज कर सकते हो. एम आई गेटिंग क्लियर गाइज? लिसन केयरफुली. अब आपको ये एनएमआर स्पेक्ट्रा मतलब कि एनएमआर स्पेक्ट्रा मतलब कि कुछ आपको वहां पर लाइंस मिलेंगे, पिक्स मिलेंगे. तो वो कैसे पिक्स मिलेंगे वो समझने के लिए अब देखिए यहाँ पर हम दो चीजें कर सकते हैं. वो दो चीजें मतलब क्या, कि एक तो हम हमारा ये अप्लाइड मैग्नेटिक फील्ड, सॉरी लेट मी टेक अनदर पेन. हाँ, एक तो हम हमारे ये मैग्नेटिक फील्ड चेंज कर सकते हैं, या फिर हम हमारी ये रेडियो वेव्स को बढ़ाते हैं. और मतलब एक कुछ तो भी कर सकते हैं. एक तो मैग्नेटिक फील्ड बढ़ाओ मतलब H0 बढ़ाओ, या फिर आपकी रेडियो फ्रीक्वेंसी बढ़ाओ, दैट इज ओमेगा. एंड बोथ ऑफ दीज आर डायरेक्टली प्रोपोर्शनल टू ईच अदर. दैट रिलेशन इज ओमेगा इज इक्वल्स टू gamma into B0 or beta, you can say. What is that? That relationship is nothing but omega. Sorry, I made one mistake here. H0 it is. You see, H0 B0. See now, what is mean by this H0? H0 means applied magnetic field. Applied magnetic field or applied field which is in Gauss. ये H0 मतलब क्या, applied field. कौन सी फील्ड अप्लाई कर रहे हैं हम यहाँ पे, वी आर अप्लाइंग हियर मैग्नेटिक फील्ड. एंड ये जो कुछ भी मैग्नेटिक फील्ड है, ये मैग्नेटिक फील्ड आप जब अप्लाई करते हो तब ये न्यूक्लियाई मूव हो सकता है, जब उसको स्पेसिफिक एंड प्रॉपर अमाउंट ऑफ रेडियो फ्रीक्वेंसी या फिर मैग्नेटिक फील्ड मिल जाए तब. फिर क्या हो सकता है, विथ द हेल्प ऑफ 2I+1 मतलब कितने ओरिएंटेशन से, उसके हेल्प से आपका ये न्यूक्लियाई एक तो यहाँ पर मूव हो सकता है, ऐसे मूव हो सकता है, या फिर अपोजिट डायरेक्शन में भी मूव हो सकता है. दैट इज नॉर्थ के पास नॉर्थ एंड साउथ के पास साउथ, ऐसे भी आपका न्यूक्लियाई मूव हो सकता है. हियर आई एम जस्ट ending this session because this is just the basic of your NMR spectroscopy. What do I mean by this basic? See now, अब ये जो कुछ भी ओमेगा है, ये ओमेगा क्या है वो बताती हूँ सेशन इन करने से पहले. ओमेगा इज नथिंग बट द एंगुलर precessional velocity. Angular precessional velocity, and whatever that angular precessional velocity is there, then after what is their relationship with the another parameters, or what are the terms which are involved in omega, that is angular velocity. Each and everything I'm gonna to tell you, but in next section. Thank you so much for joining.